AJSpeller.com. In today's tutorial, we're working on a related rates problem. Here we have the radius of a sphere is increasing at the rate of 2 inches per minute. Find the rate of change of the volume when the radius is 6 inches and 24 inches. We're going to start this problem off with a diagram. So here we're going to draw in a sphere. In the front here is actually going to be like what I'm going to call like the equator that we can see, and then this dashed line in the back is a part of the equator that we can't see. So this here symbolizes our sphere. Let's put a dot here in the center of the sphere, and we're going to draw a radius from the center to the outer edge, and then we're going to label that radius R. So here's our radius labeled R. If we go back to the question, we see that the radius is increasing at a rate of 2 inches per minute. So the radius is changing over time, and that change over time is 2 inches per minute. What we need to do now is figure out an equation that we can use to relate to this particular problem where they're asking for the rate of change of the volume. Well, we know that the formula for volume of a sphere is volume is equal to 4/3 pi r cubed. So what we need to do now at this point is take the implicit derivative of this formula over time, or with respect to time. So here we end up with dv dt is equal to 4/3 pi, because this here is a constant, a number in front, so that comes out, that stays out front. Now we have r to the third. We need to use the power rule on that. Well, that means that the exponent of 3 comes out front as a factor. We keep the variable r, and then we decrement the exponent, so that becomes an r squared. And because we're taking the derivative with respect to time, we have to put or tack on the factor dr dt. So now at this point we can do some simplification. We have 3 in the numerator and denominator, so those cancel. So you're left with 4 pi r squared dr dt. And now it's just a matter of just doing some simplification, doing a substitution. We see we have a variable r. Well, we have values for r. We have a snapshot at 6 and a snapshot at 24. And we have dr dt, which was given, which was 2 inches per minute. And basically what this is going to tell us is how much space this sphere is taking up at when the radius is at 6 and 24. All right, so let's write in, or let's create these snapshots. All right, so for the first one, we want to figure this stuff out when r is equal to 6 inches. All right, so we're going to take the dv dt. We know we have a 4 pi, and then we have r squared. Well, r in this case is 6. So we have 6 inches, and we're going to square that, and then we multiply that by dr dt, and we see dr dt is 2 inches per minute. And now we just do our multiplication. Well, we have 6 squared times 4 times 2. Well, that's going to turn out to be 288. We have a factor of pi, so we multiply that here. And then we have inches squared times inches. Well, that's going to be inches cubed. And it's understood that everything here is over 1, so we have 1 times minutes to just give us minutes. So we see that when the radius is 6, the volume is changing at a rate of 288 pi inches cubed per minute. All right, let's take a look at our next snapshot. In this snapshot, we want to figure out what's going on when the radius is at 24 inches. Again, we're going to rely on dv dt, which is what we just calculated. We know we have 4 pi r squared. Well, r squared is going to be 24 inches squared. And again, all I did was take the 24 inches and substitute it in for this r right here. And then we tack on the factor dr dt, which is 2 inches per minute. So times 2 inches per minute. And again, all this is understood to be over 1. And then we just do our multiplication. We have 24 squared times 4 times 2. And that becomes 4,608. We have a factor of pi. And we have the units, inches squared times inches becomes inches cubed. And then we have 1 times minute to give us minute. So we see that the moment at which the radius is 24 inches. We see the volume is changing at 4,608 pi inches cubed per minute. Alright, that sums up this tutorial by ajspeller.com, and as always, thank you for watching.